Everyone, I'm going to show you today briefly how to use Root, a much used tool or framework for analyzing data in nuclear and particle physics. So you get Root, the data analysis framework Root, from root.cern.ch. You download the program from here. To install it, you've got two options. You can either, if we go into and have a look at the latest distribution of Root, you can either download already compiled versions of the program. And here you see a list of the different operative systems it's been compiled for. So for example, if you're using Linux Fedora 26 with this compiler, then there's an already pre-compiled version of Root you can download. Or if you're using Mac OS X, then there's a pre-compiled version for you. And there's also some attempts for Windows. I'm not sure how well that works, but you can try and see how that works out. So in principle, if you go for a pre-compiled library, you should just download it. And once it's done downloading, you extract it and install it as you would with any other software you download pre-compiled and install it. Otherwise, what I usually do is I go and I download the source and I compile Root myself for my own hardware. I find that usually work a bit better, but it's up to you. You can either try to go with the pre-compiled version if you find one that matches your compiler and hardware, or you can compile it yourself. Once you've installed Root and set it up correctly, you need to follow carefully the instructions on the web page. Then you should be able to go to your terminal and type Root and press enter. And then you'll start Root in an interactive mode. And it's going to look something like this, depending a bit on how you've set it up. And it is basically a C++ set of libraries, so you need to program in C++ to make Root work properly. So, for example, you can define an integer g, and then you can give it a value. Then Root is just giving you some feedback. Okay, d is equal to 10, and then you can do things like increment d with 1. Oops. Now it's going to be 11, 12, 13, and so on. And you can also, there's many built-in classes that you can use that are useful for analysis. So for example, you've got histogram classes. If we press tab after typing a few letters, you will see a long list of suggestions. Now, I know that histograms are called th1 and then d if you're filling with doubles and so on. Then I can make an instance of this class and I can call it something like h2. So it tells me, okay, you've created an instance of th1d called h2. It's got no title, just one bin, and so on. Usually it's more useful to use pointers. So then I would do like this. So you can press tab here and you can get up the different ways to declare a new histogram. quite important that what you write here matches here, otherwise it makes your life difficult. This is a title. Then it needs the number of bins. So let's say I want 1,000 bins. And I want to start with values on the axis going from -10 and up to 10, as an example. Now it's telling me, okay, this is the memory slot where this one is at. And I can fill my histogram. Now I'm going to fill it with random values. In real life, you would probably be interested in filling it with something you've measured. So I'm just going to take a Gaussian random distribution, and I'm going to give it 10,000 random values drawn from that Gaussian. Then I can use a method called draw that belongs to this class. And I want it drawn as a histogram, so I use this option. If you're wondering about all the classes and all the options and everything, you need to go to the documentation on the Root website and read. So, okay. There's my histogram. You get this little box here that tells you how many entries, what the mean value is, and the standard deviation. Here's my chosen title. There's by default no values on the axis. You need to add that yourself. You can do that, for example, by going to the editor and clicking like that and entering a title. You can center it if you like, but you could also do it from the command line. Then you need to get the x-axis like that, and then you need to set title. So now I gave it a new axis title. And you can see that the canvas has been updated with a new axis title here. We could have done that for the y-axis as well. You can see we've got a title here, and we could have changed it here as well. Okay, we can close the window if we like. There's also two-dimensional histograms. Works in pretty much the same way. Only that now I first give the x-axis, and then I give a y-axis. If I draw it now, I get something two-dimensional. It has no entries yet, so it's just an empty canvas. Okay, if I quit Root now, oops, I got some error. If that happens, you can just type many Qs in a row and it will usually quit. Yeah, it's a bit hard to know why these things happen sometimes. It's usually nothing to worry about, but the point is just that if we do that, then all the memory of what you did before is being wiped out. So if we check for the integer we defined earlier called d, it tells you that, okay, it's an undeclared identifier. So all the memory has been wiped out. There are many different classes available in Root, and you should go to the documentation if you want to learn more. You can go to the reference manual. where you can read about all the different classes like this. I usually use this one in the way that I would search up the term I'm looking for. So if I'm interested in histogram, I would try maybe to do like that. And see, okay, so there's some histogram tutorials here I can have a look at. In addition to the reference manual, there are user guides. Those are quite useful. You have topical manuals, and in a nutshell,